Okay, so I'm on page 20 of your packet, and I'm going to be talking about greatest common factors. So part of what you guys need to have under your belt going into this next unit called rational expressions is factoring. So I know this is kind of cut off, but this is titled Factoring Review. And the first most important step to knowing how to factor is knowing how to take out a greatest common factor. So let's look at number 4 here. I have negative 4k cubed plus 16. I want to figure out what common factors there are between negative 4k cubed plus 16. Now I know this doesn't have a k, so they have no k's in common, but I know both have a 4 in common. Sorry. So I know that I can take out a 4. In fact, I will probably want to take out a negative 4. You can either take out a 4 or a negative 4. So if I take out a negative 4, that means all I have left in this first term is k cubed. If I take out a negative 4 from the 16, I'm going to be left with a negative 4. Now, if that confuses you, we're used to distributing more than taking out a greatest common factor, but now we have to be used to taking something out. If I were to distribute this, let's say I distributed the negative 4, I'd get negative 4k cubed, and I distribute it to my second term, I would get negative 4 times negative 4, that would give me a positive 16. So I want you guys to get in the habit now of taking a greatest common factor out. Let's look at number 6. Both of these terms have a 4. So I know that I can take out a 4. And both of those, so this term has 4 k's. This term has 2 k's, but there's still 2 k's in common. So I can take out 2 k's. Well, that means here, if I took out 4k squared, I took out the 4, I took out 2 k's, so I only have 2 k's left. Here, I took out everything. That doesn't mean that you leave it blank. You always have to have a 1 there, because when I distribute it, if I were to distribute this back in, 4k squared times the 1 would give me 4k squared. If I had just 0 there, 4k squared times 0, that would go to 0 and there'd be nothing there. So make sure you have that 1 there. Let's do 12 as an example. I'm taking out a greatest common factor. So let's look at my v's. I have 5 v's here, 4 here, 3 here. That means every term has at least 3 v's. So I can take out 3 v's, a maximum. Let's see what my numbers have in common. Negative 20, negative 12, negative 4. Negative 4 can go into negative 12. It can also go into negative 20. So I can pull out a negative 4. So I'm pulling out a negative 4v cubed. So if I pull out a negative 4 from a negative 20, I'm left with positive 5. And if I double check that by working backwards and distributing, negative 4 times 5 gives me negative 20. So that's right. And if I take out 3 v's, I only have 2 left. If I take out a negative 4 from that negative 12, I'm left with a plus 3. And I can, again, check my work by distributing back. Negative 4 times 3 would give me the negative 12. And if I take out 3 v's and I had 4, that means I only have 1 left. And here, I took out the entire term, so I have to have that plus 1 there. Let's do one more. Let's do 18. Now, this one has 2 x's, this one has 3 x's, but this doesn't have any x's. So there's no x's in common. Let's look at my numbers. 20, 15, and 20. Well, it looks like they're going to have 5 in common. So I can pull out a 5. So I'm left with 4 here, and I can go back and 5 times 4, I know that would give me 20. Plus, if I take out a 5 from 15, I'm left with 3x squared. And here I'm left with 4x cubed. So that would be my answer there. Okay, so this should be enough to get you through numbers 1 through 20, taking out a greatest common factor.